Now we'll show the code that implements the loop that performs this sequence of steps 60 times a second. The main step being render, where the batched meshes connect up to the rendering pipeline and then draw themselves. So this is the Windows Store version of the code. We'll look at the Win32 briefly at the end. There's not really much difference. So the run method on the view provider object is one of the methods that the system calls. You just have to implement a handful of methods, and it's essentially just a loop while the window's not closed. Depending on whether the window is hidden or not, we do some processing of events, and then we call the update and render. That's really just short for update, clear, present and render. So let's see what that does. Essentially it just calls this this class that represents the graphics hardware, just delegates the work off to that, and then it's done. So let's go into that one. This chunk here, we don't need to go into the details, but this just makes sure that create buffers, which we looked at in the last video, only happens once and only after the all the async and any other initialization work is done. So then here are the four pieces: the update, the clear, the render and present. So let's just look at those one at a time. So update, we're calling this on a pointer to a base, a scene base. So if you've derived from scene base, if you've got your own scene, then of course that gets called. In that case, in our case, that's what I've done. So I've overridden update. First thing I do is call the base class, and then just do a very simple rotation based on the current time, and I get that from a little timer class that I pass in. So that's update, and then clear views, clear output merger views, which is the last stage in the pipeline. So the important thing here that we're doing is we're just we have to set the render targets again each frame. So on the output merger, so that is the render target view, and then we're also getting hold of the depth stencil view. Those are the two targets that we set when we were doing the original initialization, and then we just clear the render target view, which is essentially what gets onto the screen, and we just pass that clear color in, whatever color we want to clear to, and we clear out the depth stencil view as well, so we can start rendering into it afresh. And then the render piece, we call that on the scene base again, just like we did, just like we called update. So I could override render. I haven't actually overridden render in the skeleton scene, so we can just go straight into the base implementation and see what happens. Actually, I should have said about update. Let's just go back a little bit. So update, remember when I was saying that we call the base class in our update, all I do in there in the base class is I just poll to see if there's a game controller attached, and if so, I just make changes to the view matrix so that we can apply that. We'll see that in a moment. So then going into this render, which is the third stage, we get hold of immediate context, pointing to the immediate context, and the context is the pointer that represents or the object that represents the rendering pipeline. So that's the thing that we attach all those resources to, that we use the device to create for us. And the main thing we're doing here is calling render mesh batches on ourselves. So let's go into that. It's right here, and essentially just for every mesh batch that we have, and remember mesh batches are an optimization. We just gather all meshes together that share the same input layout and shaders. So we only have to set that stuff once per mesh batch. Set it once for a number of meshes. So two things we're doing here for every mesh batch, just calling set state and then render. So the set state is for the mesh batch itself. We're just going and setting the VS stands for vertex shader, set shader, pixel shader, set shader, and these are those smart pointers that we got from create vertex shader and create pixel shader. And then here we're setting the input layout, and that's the thing that we got from create input layout. That IA stands for input assembler. So that's what that's where we're sending our geometry buffers to. So that's the set state for the mesh batch. And then to render the mesh batch, essentially we ask the first mesh in the batch to tell us its primitive topology. So for example, if it's a triangle strip, then it's just going to call input assembler set primitive topology with the appropriate enum value, triangle strip. So it does that once for the mesh batch, and then for each mesh in the mesh batch, as long as it's visible, we again set state. This time the state for the individual mesh is to actually set, again, input assembler, set the vertex buffers this time, and now of course we're attaching them to the pipeline. So this is the buffer that we got from create buffer last time, and there's the index buffer going on as well. So now we're setting this particular mesh is setting its vertex buffer and its index buffer, and then it's calling we're calling render on the mesh. The important thing here, the two important things really are that in this case, during update, we actually changed the world transform of the mesh of the square that we're rendering. We changed it by rotating it, and then so this is actually this piece here, this whole chunk is essentially updating the constants that we're sending down to the vertex shader. We can go into that in more detail in a later video. It's a little bit more advanced than just the essentials. And then finally, having set all that state on the context, we then just call draw indexed, pass it our indices, and so it just essentially interprets those indices according to the primitive topology we told it, and uses those indices to index into that vertex buffer and draw a bunch of polygons, in our case just 2 polygons. So just going to wind back, go back to where we were. Present. So we're back now in our device class. Present. Really, the important thing here is that present call on the swap chain, and that's going to synchronize us to a maximum of 60 frames a second. That's really the important piece in there, and then that's update and render. So now essentially that's what that did, that's what that call did, and that's all we do each time through that loop. So let's just very quickly, 99% of that's the same as the Win32 piece, but let's just look at the Win32 version of the same thing. This is just the message loop on a Win32 app class. If the window is closed in the Win32 case, then eventually a Windows message quit gets sent, so we'll process that and return. So as long as we're not returning, we're just going to loop while true and call update and render, just like we did in the Windows Store one. This time it's update and render. It's actually in here. This time update and render is on this D3D 11 window type, and just like we saw for the Windows Store version, it's just calling, it's just basically delegating all its work off to that device. So at this point we're exactly the same as we were in the for the Windows Store version. And the scene class that we use in the Windows Store app is exactly the same file as the one in the Win32 app. Of course, most of these files under the DirectX Foundation classes folders are exactly the same. The only difference is the Win32 stuff and the Windows runtime stuff. Everything else is the same. So if I just run that Win32 app, you can see because it's using the same, exactly the same derived scene class and exactly the same everything else, it looks the same. So there's the Windows Store app on the left, Windows Win32 app on the right, doing exactly the same things.